This table is really important for not just this chapter, but also, again, chapter 4, we get to logarithms, you can do exponents, but if you take a look at the beginning of the year in the announcements, and it was also in an email, and scroll on down to the beginning, exponent rule. Here it is, it's the second announcement. Sign sheet chapter 1, 18 by 18 graph paper, exponent tables, 10 rules of exponents, exponent tables. So you do have access to this, print out your own. The more you know these powers by heart, the nicer your life is going to be. Let me point something out to you, because I like to pick on them, even though they probably don't like it. The math for A. Let's see. They even have exponents. Okay, even circle. Circle. I just emailed it, that is, we're having it in house. Okay, my bad. But I posted something that they need to know by heart. And I can tell them you need to know it by heart. And they have a memory quiz where they got to show me the, like math facts when you were in first and second grade. And they get to take it 3 times, do a calculator, and I think the best of the three scores, if the class gets the 80% average, they get to use, I will put this unit circle so all the special angle answers are basically in front of them. And they don't have to worry about knowing everything by heart. They have access just in case. But they have to prove the class has an 80% average to have access to that. Well, first shot was a 53% average. There were about 4 or 5 zeros. It wasn't a popularity. It's just like, hey, in a week and a half, we're going to do it. They had a practice sheet with everything on it. So when I say you need to know these by heart, I'm not going to give you a quiz on it. But the quicker you are with these things, the quicker you see them, the quicker you're associated with them, the easier chapter 2.3 will be, which is about square roots. Being able to take a square root of something. Simplifying square roots. And then in chapter 4, when we're dealing with logarithms and exponential functions, dealing with all sorts of powers. Powers of 3, powers of 4, powers of 5. Now, obviously, the answer to row 1, 1 to every power is a 1. 1 to the 5th, 1. 1 to 6, 1, 1, 1, 1. Okay? Make sure you remember anything to the 0 power. This is rule number 7 on the rule of exponents. A to the 0 power is always a 1 as long as A does not equal 0. Everything to the power of 0 is a 1. 6 to the 0 is a 1. 7 to the 0 is a 1. 8 to the 0 is a 1. Don't let that one bite you. That's the quickest, easiest one to get wrong that messes everybody up. So 9 to the 0. So here's the thing about exponents. Every single power starts with the same answer. When you start with the power 0, the answer to all of these exponents is a 1. For chapter 2, the most important column is the next one, powers of 2. Because we're going to be doing a lot of square root. In order to do square roots, we've got to be able to take squares first and square numbers. Actually, the next column is a power of 1. My bad. 4 to the first, 4. 5 to the first, 5. 6 to the first is a 6. 7 to the first, 7, and so on. That's an 8, that's a 9, that's a 10, that's an 11, that's a 12. 13 to the first is 13, 14 to the first is 14. We get 15, 16, 17, 18, 19, 20, 21 to the first is 21. 22 to the first is 22, 23 is 21st is 23. We have 24, 25 to the first is 25. Most importantly, when you see 3 by itself, there is a power always of a 1. There's an exponent. Don't disregard that. There's a power of 1 right there. That's why when we go 3 times 3, we get 3 to the second power. Not just because there's 2 3s, so it's 3 squared. It's because the first rule of exponents, a to the m times a to the n, you add the powers, a to the m plus n. You add the exponent. That's the very first rule. Well, this is actually 3 to the first times 3 to the first. So this is 3 to the 1 plus 1. That's why we get 3 to the second. Now, we can't tell you when you're in the 5th grade, that's why we get 3 to the second, because that's going to go what? That doesn't make any sense when you're in the 5th grade. But it needs to make sense now because we're going to be doing, we're doing it with variables. And we're dealing with this with variables. X squared times x is x to the third. When you're factoring, you got to figure out what times what is x to the fourth. X squared times x squared would be x to the fourth. How many different ways can I factor this and get the same answer? Dealing with exponent, rules of exponent. Squaring something. So 3 squared, 3 times 3, this is the most important column for chapter 2. Good enough. 4 to the second is 16, not 8. I saw that on a lot of exams. 4 to the second was an 8. 5 to the second is 25. 6 is 36. 7 to the second is 49. 8 squared is 64. 9 to the second is 81. 10 to the second is 100. 11 to the second is 121. 12 to the second is 144. Now, those are all the ones that are on a Peachy folder. You guys know what a Peachy folder is? That's that folder with all the athletes on it, and they have little papers inside. I mean, I know you guys have the track folder, whatever, but when I grew up, they had the Peachy folder, we had the tennis player, football player, track player, and it was like, never mind. But on the inside, there's a times table. On the inside cover, there's a little times table, and it went 12 by 12. Okay. And that was basically what they held it to, was 12 by 12. So you ended up with 144. I know a lot of my friends, they do cut that out and try to sneak it somewhere on the desk. You had those desks that opened up, so we put it right on the lid. And yeah, because of course, teachers aren't going to go looking at the lids as, after the day was over. $13 squared is 169. 14 squared is 196. 15 to the second is 225. 16 to the second is 256. 17 to the second is equal to 289. 18 to the second is 324. 19 to the second is 300.
71,
What?
71.
That's 71, I think it's 61. This one always gets to be 350, I think it's 61. Yeah, 161, or 361. 20 squared is 400. 21 squared is equal to 441. 22 squared is equal to 484, I believe. Forty-four. 23 squared is 400, no, 500, 529. Yep, 529. 24 squared is equal to 576, and 25 squared is equal to 645. And then the rows get, or the columns get a little shorter. Because we don't need to know some of these higher powers. I mean, you do get to use the calculator. But you should know your cubes. You should know that 2 to the third is 8. Because you're just going to multiply this last answer by another 2. This 2 to the 0 is a 1. And then when you raise it to the first, you take this 1 times the 2. 2 squared, you're going to take this answer times the 2. 2 to the third is just this answer to the 2 squared times another 2. So now I'm just going to fill in this row. I'm going to go that way. 2 to the fourth is 8 times another 2, so that's 16. 2 to the fifth, you're going to multiply this by 2, so that's 32. 2 to the sixth times 2, that's 64. 2 to the seventh is 128. 2 to the eighth is equal to 256. 2 to the ninth is equal to 512, and 2 to the 10th is 1,024. Your powers of 2. You should, that all the way across. It's not hard to double when you double the number. Powers of 2. Powers of 3 aren't bad either. 3 to the third, 9 times 3, 27. 3 to the fourth, 27 times 3, 81. 3 to the fifth, 81 times 3 is 243. 3 to the sixth, 243 times 3 is going to be 729. 3 to the seventh, so times 3, so that's 7, so 2, so 6, 8, 2,187. Three to the eighth, 65, 61. And 2 to the ninth. 19,683. And 2 to the 10th. 9, 2, 6, 69,049. But honestly, right about here is good. 3 to the 6. And you'll see why in a second. You will see why in just a second. Multiply by 4. This one's going to happen a lot. 4 to the third, 64. 4 to the 4th multiplied by another 4, we get 256. 4 to the 5th multiplied by another 4, we get 1,024. 4 to the 6th, we're going to multiply by another 4, so we're going to get 4,096. 4,096, and 4 to the 7th multiplied by another 4, we get 16,384. And 4 to the 8 is equal to 16. 65,536. Okay, this is the last one. What's the last one? 4,096. 16,384. All right. Times another 5. 5 to the 3rd. This will be 125. 5 to the 4th is 625. 5 to the 5th is going to be 3,125. 5 to the 6th is going to be 2. 6. 15,625. The 3rd is going to be 216. 6 to the 4th. My arm's getting tired. 7 to the 3rd is going to be multiplied by 7, so that's going to be 343. 8 to the 3rd multiplied by another 8, so that's going to be 512. Multiplied by another 8 to the 4th, and we'll see why this again. Point out why that can happen again. 4,096. 9 to the 3rd, 729. 9 to the 4th, 3,000. No, 6,561. And then this one should be the easiest one, besides the ones. 10 to the 3rd is 1,000. 10 to the 4th is 10,000. What am I doing? This 5 zeros is 100,000. A power of 10 is just that many zeros. 10 to the 6th would be 6 zeros, so that would be 1 million. And so on. Powers of 10 are just that many zeros. And then I did cut it off, but powers of 20. 20 to the 3rd, let's put it up here. 20 to the 1st was 20. 20 to the 2nd was 400. 20 to the 3rd is going to be 8,000. 20, hello. Let's take this apart. We see numbers that repeat. Look at 2, look at the 4, look at the 8. The answer's on the 2. 2, 4, 8, 16, 32, 64, 128, 256, 5, 512, 1,024. Look at the 4s. We have a 4. So does 2. We have a 16. So does 2. We don't have a 32, but we have a 64. So does 2. So does 4. We have a 256 here. So does 2. We have 1,024, and so does 2. And that's because 4 is a power of 2. This 4 to the 5th is 1,024, and this 2 to the 10th is also 1,024. Because this 4 to the 5th is the same as 2 squared to the 5th power. 4 is a 2 squared, isn't it? No? It's 4 equal 2 squared. Yeah. Does everybody agree? Because if you don't see it, then I need to explain it, because if you're not seeing it, and if you're not saying anything, I don't know if you get it or not. And if you don't get it, I need to make sure you do, because I can't go forward. This is what I'm talking about. I'm talking about being engaged, not just sitting in silence, which is what a lot of you have been doing. You're waiting for something to happen. I don't know. Well, you got to make something happen. It's a simple question. Does 4 equal 2 squared? Yeah. That's all you have to say is, yeah, I'm not waiting for somebody to raise their hand. I've never had anybody raise their hand in the last 35 years of teaching. I'm not that kind of teacher. So I can rewrite 4 to the 5th as a 2 squared to the 5th. And then here we go, back to the rules of exponent. What did I say in the first 2 weeks of class? The 10 rules of exponents are going to be all year long. It's going to be all your life long if you're going to be a STEM major. That's why it's so imperative, so important that you know them. You have to know the rules of exponents, because this right here, a to the m raised to the nth power, a power to a power, you multiply the exponents. So this would be 2 times what? This is 2 to the 10th. And that's 2 to the 10th. That's why we get the same answer. So if I know what power is 2 is, I know what power 4 is. Vice versa. Right here. 3 to the 9. 9 to the 3rd is 729. And over here, 3 to the 6th is 729. 9 squared is 81. 3 to the 4th is 81. 9 to the 4th is 6,561. 3 to the 8th is 6,561. Because 9 is a power of 3. I might have to rewrite that problem, 9 to the 4th, as a power of 3 instead. Because we're going to be solving problems that are like this. 9 to what power is equal to, let's go with 27. 9 to what power is 27? 9 to the first is 9. 9 squared is? Anyone? We missed 27, didn't we? So we can't do that problem because it's not a integer. But you know what? Rewrite this. This is 3 squared to the x equals 27. So that means this is 3 to the 2x. And 27 is 3 to the third. So that means 3 to this power equals 3 to that power. So that 2x has to equal a 3. These exponents have to be the same. Therefore, divide by 2. That power has to be 3 over 2. 9 to the 3 over 2 is equal to 27. We're going to get exponents that are fractions. And that's what a square root is. A square root is an exponent that's a 1/2. Because if I can go 1 to the 0 and 1 to the 1, and 4 to the 0, 4 to the 1, what about 4 to the 1/2 power? Something in between. It's going to be a 2. It's a 1/2 power is a square root. A 1/3 power is a cube root. 1/4 power is a fourth root. So you have to understand exponents. This right here, the powers of 20. This is just right here, 20 squared. 400 is the answer because I can factor this. This is 2 times 10 to the second power. And that's because of rule number 3. Pull the rules back out here. A times B to the M is A to the M times B to the M. If I have a product to a power, each factor gets that exponent. So I factor 20 into 2 times 10. So that's 2 squared times 10 squared. 4 times 100 is how we get that 400. I can do anything that has a 30 to the second. That's 3 squared times 10 squared, so that's 900. 40 to the second, that's 4 squared times 10 squared, so that's 1600. 40 to the third, that's 4 to the third times 10 to the third, that's 64,000. Because you've got to work those exponents. And then when we take the square root, this is the square root of 4 times 3. Or let's put it this way. I'm going to do this the way I will not teach it. It's 12 to the 1/2, which means it's 4 times 3 to the 1/2, which means it's 4 to the 1/2 times 3 to the 1/2. 4 to the 1/2 is 2 times 3 to the 1/2. So that's 2 square root 3. That's not how I'm going to teach it, but that's exactly what happened. It's all because of the rules of exponent. Because we don't make the shit up. It's based on the rules. You follow the rules, you get the right answer. But you got to learn the rules. And I will continue with the review sheets, the quiz preps. So you know exactly what to expect. But if you don't do them or ask questions about them, do them on your own. They don't do you any good. Before you ask me, and I'll say it again at 10 o'clock because I know we're going to want to know. Can I still pass? Whether you pass the class or not, that's your concern. My concern is about you learning. I dropped 2 lowest quiz scores. The final replaces your lowest test score provided the final is higher. That's all I do. Now, your job is to get better test scores, higher than this one, and higher quiz scores, so lower quiz scores that you might have, get dropped. Higher homework scores, and do your homework better than you did before, so you learn it before you actually come and take the test. This is in your hands. And if I'm not explaining it well enough, you have to say something so I can explain it differently. Not you. I'm just a fool up here trying to help. So come on back in.